Right, hello and welcome everybody. Thanks for joining us today. As you are aware, we are going to be talking about the impact of robotics and AI. We are representing UCL Computer Science, and I'm here today with Dr. Igor Gapanov. He is the associate professor, he's an associate professor, and he's also program director of the new MEng in Robotics and AI. That's a 4-year undergraduate program based at UCL East, which you can see in Igor's background. And the program launched this September, so it's the first year we've had students on the program. Igor's going to talk for about 20 minutes, and then we'll take some questions. If you have any questions, please put them in the Q&A rather than the chat. You'll find the Q&A at the bottom of your screen. And we've also got Ashmita joining us in the background who can help answer certain questions about applications and the admin side of applying to UCL. And the session will be recorded. I hope that sounds okay. And now I'm going to hand over to Igor.
Thank you so much, Vajia. All right, so let's get it started. Today, as Vajia mentioned, I'm going to discuss the impact that robotics and artificial intelligence have had to date on our society, on our lives, and about the future of these two exciting technologies. Today, basically, this is what I'm going to focus on. First, I'll start off with the application areas of modern robots. Then we'll discuss one of the most important, probably, areas of robotic applications, which is industrial robots. And more importantly, we'll discuss the effects that industrial robots have on the job market. Then next on, I would like to discuss service robots, which is also a big class. And yet this is somehow lesser known one. And in particular, I would focus on a certain type of service robots, namely exoskeletons. And I would like to conclude the talk with the implications and impact of artificial intelligence. And we will see a couple of examples of how we are using different AI techniques and methods today. And of course, we will end with a round of questions and answers, and I'll be happy to answer any questions about anything I talked today or studying at UCL and studying our program. So let me start with applications first. Probably most people imagine something like this when they hear the word robot. And indeed, this is a very common application. We are using robots in factories for decades now. And normally, this is something that you see in the newsreels and sometimes movies as well, robots working on a seemingly endless conveyor line with almost no people next to them. And in fact, robots have this, usually the protective fence around them to prevent any people from accidentally wandering into the working zone of this robot. And indeed, the impact of robots on manufacturing and automation has been huge. But of course, they are also used widely in various defense and military applications, including the unmanned aerial vehicles. But more and more, they are starting to enter the areas which were traditionally kept robot-free, and that is various domestic applications, some of which we are going to discuss today. Even more so, robots are being used in agriculture, and that includes a variety of applications, including planting, harvesting, removing weeds, and many others. Also, we are seeing a rise of various autonomous ground vehicles, and they're used for transportation now. That includes both passenger cars, but also trucks. And in big part, they're also used now in many applications in logistics and warehousing. So this is automatic delivery of parcels and goods, delivering different parts within the certain industrial or manufacturing setting, say from one part of a warehouse to another, and many others. And probably in the future, this will include door-to-door, or rather goods delivered to our doors, the goods that we, for example, buy online, and that includes food as well. And because industrial robots is such a huge, an important player in today's life, everyday's life, I just wanted to briefly show you the numbers. So it's safe to say that by now there are over 4 million units of robots installed worldwide. And just try to imagine how many engineers are required to service, to repair, to install, to reprogram them for, say, every new part that robots need to be making. And of course, the growth has been staggered somewhat by the recession in 2018, but then recovered quite quickly. And in fact, since 2017, the number of units installed of industrial robots is, growing on average by 13%. And this obviously was further boosted by the pandemics, because people have seen a huge need and huge importance of unmanned technology. And of course, robots don't need to be quarantined, and they can, still keep producing the goods that they are producing in the factory setting. And despite the slowdown in the economy in 2023, this did not actually affect the robot installations. And if anything, the demand is still higher than it was pre-COVID. And Asia is the fastest growing market in the world. But in fact, almost 80% of all industrial robots are installed across just 5 countries, which are China, Japan, USA, South Korea, and Germany. And most important applications of industrial robots include manufacturing of electrical and electronic parts, and then, of course, car assembly. So these two, they are almost, jointly share the lead in terms of applications. But also robots are used in a variety of other applications, including food, and that includes both manufacturing and packaging. And it's fair to say that many things that we use in everyday life have been either manufactured or somehow assisted by, their manufacturing was assisted by robots to some extent. And sooner probably the percentage of these goods will increase. But another fear that many people have is that because robots are used wider and wider, they will be displacing human workers, and that can obviously lead to various societal and economic crises. But in fact, studies show that that is not the case. The fact is that actually it's labor shortage that is apparent in many countries, and that especially is true for small and mid-sized enterprises. And say in the European Union alone, almost 3/4 of the companies, they report that they are short of skilled workers. And that's where robots come in. And actually, many young people who enter the job market, they prefer to work in a company that uses something that we can dub the technology of the future technology. And of course, robots and AI, artificial intelligence, are big players in that market. So the image of the company is very, very important. And also robots are most often used to perform one of those 4D works, such as dull, dirty, dangerous, and difficult. And of course, people who find themselves working alongside robots, they have more opportunities to, for professional development, for growth. And in fact, there is a bunch of evidence that automation does not lead to job substitution. So we do not close workspaces for people. Instead, we reallocate people, and often people who were performing routine or dangerous tasks, they're now moved into the higher skilled labor sector, where, for example, now they find themselves being complementary, being essential actually for the manufacturing process, because now they'll be programming robots. And this is something that's commonplace in many of the factories, where workers who used to be just manual laborers in the past, or engineers for automation line, now will be moved into servicing and programming robots. But also this creates a lot of lower skill jobs, namely for service and maintenance, but also for many other duties. And in fact, there are several papers, and one of them is here, that said that actually productivity growth, thanks to robots and probably to AI as well, is employment augmenting. So the widespread use of robots creates workplaces, and not the other way around. But also why this works is that robots increase productivity, obviously, and the competitiveness of factories and firms, the companies that use them. That in turn leads to increased demand because now robots can produce more quality and probably cheaper goods. And that obviously creates new job opportunities because of the growing manufacturing output. And now it's not just that robots are entering the industries, big industries and big factories. The future is robots and people working together. And that also includes small enterprises. For example, there are now several robots which are safe to be used around humans called cobots. And they can be installed, say, in a garage to help a small, manufacturing facility and applications which were inaccessible for robots before. So there are actually many new use cases of robots which appear every day. And these lead to many governments and companies focusing on providing the right environment, the right skills to nurture the current and the future workers. And of course, that has already led many governments and universities creating, sponsoring, trying to develop these, fertile environments rather for people to learn the skills in robotics and AI. And that includes, of course, many universities such as UCL opening respective educational programs which focus on robotics and AI. And undoubtedly, this is one of the most promising areas of the future in engineering. And now that we've seen the impact of industrial robots, I would like to shift a little bit to probably a lesser known area of robots. These are called service robots. So essentially, this is everything that does not participate directly in the manufacturing process in the factory setting. And there are many applications. So there are robots for transportation and logistics, including the warehouses. And many of the robots in transportation category, they include, for example, food and beverage delivery in restaurants. So if some of you have seen those, these fall into that category, transportation and logistics. Then there are many robots that are used in hospitality now. For example, these are robots for mobile guidance, information, telepresence, and they're used in a variety of public venues, including museums, airports, public fairs, exhibitions, and such. Then there are many medical robots. For example, last year alone, there were almost, I think, 5,000 surgery robots. It's very similar to the one you're seeing on the picture, sold worldwide. Then agriculture robots, as I mentioned before, and that includes both from growing crops and harvesting them to, say, milking robots and robots for cleaning. And professional cleaning, especially the floor cleaning, is a big category. Again, this is very important due to the shortage of labor, and these robots work perfectly in the areas with a large floor space, for example, like at airports. But also, there are many robots for consumer use. For example, over 5 million of robots were sold last year alone. And these are mainly domestic household robots, such as vacuum cleaners. And some of you may have one at home. But also gardening robots. For example, robotic lawn mowers now. There are more than 1 million of devices sold last year alone. And these numbers are growing continuously. And if anything, we will see the explosion of robots like this in the future. And it's needless to say that for drones, something that has been, an area of robotics that has been used very sparingly 20 years ago, even 10 years ago, now they find themselves being used by many households worldwide. And many experts think that the next area that can explode is the exoskeleton area. And exoskeletons, for those who've never heard of this, these are basically external devices, hence the term external skeletons, that are used mainly for 3 purposes: to restore the lost functions. For example, if humans are not, for those who are not capable of walking anymore, they can still do so with an exoskeleton. Then to increase the strength of human muscles, like you can see on the right-hand side, and also to support some forces. For example, if laborers' work involves supporting a weight over their head, there can be an exoskeleton which takes or lifts some of the load from them, so they're not as fatigued as they were before. And these robots are finding greater and greater use in many applications, including industrial and medical. And I'm going to give just a couple examples of these robots and how they're used more extensively these days. So the robot that you've seen on the previous slide it can be used to lift heavy load. And this is obviously useful in a variety of tasks, daily living and professional tasks. That includes helping all those workers around the warehouses, all the people who are involved in, say, goods delivery, being loading, or unloading from the truck, groceries delivery to our doorsteps, those workers who lift bags in airports and such. And these robots like this have been tested significantly, as well, extensively rather, for the past, or over the past at least a decade now, that they're permeating the consumer market. Then another type of industrial exoskeletons is wearable and soft systems which augment certain body functions. For example, this is an example of a device called Iron Hand, which helps manual laborers in various tasks such as gripping, cutting, holding, because obviously this is a very tiring job. And using such robots in industry, not only does it help boost productivity, but also it significantly decreases the risk of injury that is sustained by the workers. And robots like this, they are finding wider and wider use in various industrial settings these days. But of course, apart from the industry, there is a big demand for medical systems, because humans sustain injuries, for example, that may prevent them from performing activities of daily living. And one common disease, for example, is stroke. And many people who are affected by stroke, depending on the severity, they find it very difficult to restore their normal gait or walking. And in the traditional rehabilitation, it takes 2 or 3 nurses, as if you've seen in the beginning of the video, to help people restore their functions. And simply we don't have enough nurses and doctors, medical specialists for each of the patients. And so devices like the Locomat here are becoming more and more common. And today there's been over 1,000 devices installed at various hospitals around the world. But of course, this device can be used statically in a hospital. But what about those people who need a device like this at home? And indeed, there are many advances in this area as well. So, for example, the Restore exoskeleton by the Rework Robotics was the first soft exoskeleton, which does not feature any rigid links around the human body, that was licensed by FDA, Foods and Drug Administration, in 2019 for the medical use. And as you can see, the system is quite compact. And essentially what it does is it helps the lower limb while that was affected, for example, by the stroke during walking. And instead of using this for rehabilitation only in the hospital setting, you can wear this device either underneath or on top of your clothing. And this device can help you walk, which is, again, a very big advance in technology, and is extremely useful for many, many people out there who experience difficulties walking due to many of the diseases that can affect this. But so these 2 robots are for rehabilitation and assistance, but sometimes there is no rehabilitation that can help people. For example, spinal cord injury is a very, is a very severe injury. So it can be sustained by those who, say, get into a car accident. And in this particular case, if you have an injury to your spinal cord, then you lose, you cannot restore the functioning, say, of your legs. And you end up in the need of a certain device which will help you navigate, help you go out there and navigate in the environment. Very commonly, this is a wheelchair. But again, there are many disadvantages to using a wheelchair, including accessibility, right? And just too many places, unfortunately, are still inaccessible to the wheelchair users. And that is why, instead of a wheelchair, there is an opportunity to use a medical exoskeleton. For example, this is the device called Rewalk by the same company, as you've seen on the previous slide. And it was licensed for in-hospital use over a decade ago now, but also it can be used, by persons at home. So you can acquire this as a commercial device and wear it, right, and use it to navigate either within or outside your house. And also, which is very important, it supports both sitting down and standing up movement, something that many people many disabled people they have difficulties with, of course. And for example, this device like this in 2012, a person named Claire Lomas, she became the first person in the world to complete the marathon. So she's paraplegic, means she doesn't have, she lost control over her legs. And yet, while wearing this device, she has completed a marathon, a London Marathon, which is, for those who don't know, over 42 kilometers long contest, while wearing this exoskeleton. And of course, doctors, they did not allow her to complete this in one day, because this is obviously poses a huge risk to health of people whose lower limbs are affected. But this was a big and famous action which helped her raise over £200,000 in support of the research and rehabilitation for the spinal research. This non-profit organization. And so these systems like this have been around us for over a decade now, and there is more and more development of such system. And in big part, this is helped by competitions like the Cybathlon. So essentially, this is similar to Olympic Games, which and also it happens in, to have different categories. And this is, for example, a snapshot of the exoskeleton category. And essentially, this is a race. There is a course, there is a track in which the wearers of the exoskeletons, these are all people with disabilities, they have to complete the tasks which they face most commonly in everyday's life. For example, sitting down and standing up, navigating, stepping on certain areas, then climbing stairs and descending. And the best scientific research laboratories, as well as industrial manufacturers, compete in these prestigious events with their exoskeletons and the athletes who wear these exoskeletons. And that event like this, it helps boost the technology and the development of various robotic and AI technologies across the sector. And there has been another competition in 2020, and there'll be more of this. And this was a hugely successful competition, which helped showcase how important robotics and AI are for modern society. And of course, hand in hand with robots, there is artificial intelligence. And of course, many of you are aware that AI is superior to humans in its data processing and pattern recognition capabilities. And of course, many or even most probably modern robotics applications will be using or leveraging artificial intelligence to a certain extent, be it autonomous vehicles, for example, like autonomous taxis and cars. They perceive the environment, they make decisions in real time, and then navigate changing unstructured environments, which is a big and very important and hard task. Then space exploration, of course, it's a hazardous application, and robots are often sent where humans cannot go. That includes both places on Earth and, of course, outside it. And moon rovers and Mars rovers are just a few, couple examples of such systems. And they do perform autonomous navigation and analyze the data. And manufacturing, of course, for quality control, and many other applications for decision-making, for logistics in the warehouses. So these are just a few examples of how various applications of artificial intelligence and where these methods are used in the area of robotics. But of course, AI is not limited to robotics and is being used extensively, for example, in healthcare, in areas such as medical diagnosis. Very often, AI methods can have higher degree of accuracy and speed than human doctors. Of course, this comes with a caveat that they must be trained on high quality and extensive data sets. But there have been several algorithms of AI for example, lung disease diagnosis, which came especially prominent during the recent pandemic. And AI methods can help boost or optimize drug development processes. Now, another big area is the NLP, or natural language processing. And everyone who has a sort of home assistance with natural speech processing capabilities, or even your smartphones, have used different AI techniques for this, right? You may have not thought about this, but that's exactly what's under the hood of those devices. And that includes chatbots and automatic translation and captioning, which hopefully will help us communicate with each other more effectively. And of course, there are many applications of AI in image and video analysis. That includes both identification, labeling of people and objects in various images and videos. And that is used again, starting from the algorithms which help you unlock your phone with your just by looking at it, or obviously for surveillance and safety purposes. And just to conclude today's talk, I want to leave at the 4 points which are listed here. So first, the future without robots and AI is inconceivable. Now there are more and more applications which require robotics and AI. And of course, the global shortage of skilled labor, and both high skilled and lower skilled labor, that further boosts development of various systems, technical engineering systems. The wider spread of robots and AI, it creates workplaces, and there are many startups and younger, smaller, bigger companies that are centered around AI these days. Now, robots and AI and their use is integral to tackle global challenges. This involves addressing global hunger, sustainable agriculture, climate change, help aging population, and many others. And last but not least, robots can help us achieve something that we otherwise would not be able to. Space exploration and exploring hazardous environments on Earth is just one example. And so it is very exciting to see the development of robots and AI in the near future. And with this, I would like to conclude today's talk, and I'll be happy to answer any questions.
Thanks, Igor. That was really great. There's so many interesting developments happening as you've demonstrated. We do have one question, but if other people watching have questions, please do put them into the Q&A at the bottom of your screen. So can you see the question, Igor?
Is it why does UCL not offer a MEng program for this course? Is that correct? And probably I will answer this best with a slide. So if you look at the current structure of the 4-year MEng robotics program at UCL, so in year 1 we teach fundamentals. That includes 2 modules, two courses on mathematics, and also such disciplines as programming, mechanical systems, mechatronics, electronics, control. So basically everything that you would need to know about the foundational, the ground level of all robotic systems. And then later we start going into special subjects, which is advanced programming and the fundamentals of everything AI related. So that includes machine learning and reinforcement learning. And then in year 3, we top it off with various modules on sensing, networks, robot learning, robot planning, and SLAM, which is simultaneous localization and mapping. So this is to help robots navigate in the environment. And year 4 concludes with even more advanced modules such as multi-agent systems, human-robot interactions, and many others. And while it might be possible, but it would definitely find it very challenging to squeeze all these modules into a 3-year-long program, right? Because again, many modern applications, they are so complex and they require so much knowledge and experience that we found it best suited for a 4-year program, and hence we have this MEng program which spans across 4 years. And again, it is possible to take something away, but year 4 offers a very exciting, a very very cutting edge projects and modules which we do want our students to experience while studying in our program.
Great, thank you. So there's another question in the chat, which is, how long is this course? Which I think was just answered. It's a 4-year undergraduate program. And what are the job opportunities after doing this course? So do you want to talk a little bit about the type of opportunities there are?
Oh, yeah, absolutely. Again, there are a plethora of companies which are involved in robotics and AI research and development, and that includes all the companies, for example, that deal with image processing and recommendation systems. There is a big market in fintech, right? So financial technology for trading recommendation systems. Now, obviously, there is a big market for various applications, be it phone apps and software, specialized software, which deals with say pattern recognition, automatic labeling of say products and goods that you see in the video. And this is very important, say, for those large grocery retailers that need to do sorting and processing of large quantities of visual information of different goods that they offer. So both supermarkets and grocery shops. Then on the more classical robotics side, there are many exciting systems which appear every day. That includes medical robots. There is a huge development in the area of autonomous vehicles, and probably driverless taxis is one of the nearest applications which will enter most of the big cities in the world. And in fact, there have been tests of autonomous vehicles for decades now, over a decade, well, in some parts of the world. And many big companies, for example Uber, right, they're interested in driverless technology. And again, there is a big demand in the specialists who would be not only versed in theory, but also would know how to apply different techniques, different methods on practice to real robots. And so I think actually it's a very promising area. This particular program would create very would help us graduate students with very in-demand set of skills. And another question that I see is, do you think that the use of AI in robots introduces any sort of bias? And do you believe AI can be used ethically? Actually, this is also an excellent question. And it's not just something that I think, it is a fact that it is very often biased. And normally this is due to the data set that we introduce when we are teaching, various, say, neural networks. And it is very important to understand the bias in AI and to provide, non-skewed, well-distributed data sets, for example, for learning. The same goes for robots. And in fact, there have been, many famous cases of misuse or bias, which were uncovered in, industry-grade AI applications. And that is why actually in this program, in our program, we have the ethics in robotics and AI band that goes through the whole program. And in fact, starting from year one, in the mechatronics module, we have seminars on ethics in particular, and that includes discussing, negotiating biases in robotics and AI, talking about testing the systems in the wild, talking about their impact on society, and many other questions. So yes, while there is bias, it is possible to tackle it. And the first step is just to be aware of it. That's what we cover in the program as well. And the next question was, does this course only include learning about AI or also machine learning, managing statistics, and parts of biomedical engineering? So as you can see in this slide, we do cover some fundamental pieces of machine learning. And of course, we'll be talking about the foundational blocks, right, such as clustering and whatnot. But many of our examples, they are tailored to various robotics applications. Of course, we also do talk extensively about, say, image processing, and we will be studying many of the use cases and case studies. However, these images will most likely come either from, for example, autonomous vehicles, but also from biomedical applications, because we do have several of the core faculty whose main application area is medicine, and that includes navigation, segmentation, various image processing for for planning the operations, and other exciting applications. So as long as it has something to do with robotics and application, yes, it will feature in our curriculum. But for example, we will not be anchoring very heavily on various examples from, say, biochemical engineering or maybe financial trading. because again, there is just so many case studies which are pertinent to robotics. And this is something that we'll be focusing on in this program.
Thank you, Igor. I think there are no more questions. Do you have any last words you want to say about people who might be considering studying this program here at UCL?
It will be obviously very happy to see applicants from all over the world. And in fact, this year we already have a very diverse, very friendly student body. And UCL East is one of probably the most exciting places to be a student, because it's in a very new, beautiful part of London. It's still fairly central, so you'll get to experience both the main campus and the new UCL East campus, but also you'll be part of the new history of UCL, because it's a big expansion project. In fact, it's the biggest expansion project in almost 200 years of UCL history. And the teaching environment is absolutely immaculate, splendid. We have big rooms, we have great hardware. Our students have access to real robots and real manufacturing facilities. And I think it's a very exciting place to be.
Thank you very much. That's really great. So on that note, I think we will bring this to a close. Thank you for joining us today. We hope that you found this really useful, and we wish you luck in whatever you decide to do in the future. Thank you. Bye.